The IC blockchain stands out in the crypto space for its commitment to fostering collaboration between Web3 and Web2 projects. While the adoption of Web3 technology is on the rise, it's not without its complexities. Often, adoption is hindered by a lack of understanding and accessibility, especially when it comes to integrating data. The challenges of Web3 adoption. Web3 dApps aim to bridge the gap with user-friendly interfaces, but interoperability issues hinder communication between dApps on different blockchains, known as the interoperability problem. Existing solutions like bridges and wrappers introduce vulnerabilities and don't address specific data needs. For example, developers may only need specific data like token prices from a different chain, but current mechanisms like oracles and relays involve third-party intermediaries, posing trust and security concerns. A solution without intermediaries is needed to facilitate data transfer and requests seamlessly, but such a mechanism is currently lacking in the Web3 space. Introducing HTTPS Outcalls. Enter IC blockchain, which has introduced the revolutionary concept of HTTPS Outcalls within its canister smart contract. This function enables smart contracts to communicate with the outside world by fetching and transmitting data without the need for intermediaries. Moreover, because it employs HTTPS, it offers a more secure process compared to traditional HTTP. To better comprehend the difference between HTTPS outcalls and oracles, let's consider an example. Oracles versus HTTPS outcalls. Current blockchains primarily rely on oracles, not HTTPS outcalls. Imagine a scenario where a smart contract operates on Ethereum, much like Uniswap. This contract must stay in sync with a centralized exchange, like Coinbase, which deals with the same tokens. Oracles step in to synchronize token data between Uniswap and Coinbase. They ensure that token data, including price and volume, matches on both platforms, even if there's no trading on Uniswap. However, this process depends on oracles to fetch and transmit data. If an oracle malfunctions, it could disrupt tokens like ETH across various exchanges. The role of HTTPS outcalls. Here's where IC blockchain's HTTPS outcalls come in. They're integrated into the canister smart contract, eliminating intermediaries. Imagine a decentralized exchange like Sonic operating alongside Coinbase. When ICP's buying volume surges on Coinbase, Sonic's ICP price increases. To align their prices, Sonic's canister smart contract uses HTTPS outcalls to fetch IP price data right from Coinbase. HTTPS outcalls work like this. The smart contract sends a data request to the relevant network or application. Once approved, the requested data is transmitted. Subnets on the IC blockchain validate and store this data, ensuring consistency. After data transmission, nodes within the subnets on the IC blockchain perform data validation, ensuring that the data remains consistent across all subnets within the blockchain. Once this validation process is complete, the data is stored within individual subnets and made accessible through both the blockchain and dApp interface. When it comes to sending data from a dApp on the IC blockchain to external entities, the process is equally straightforward. The HTTPS outcalls function simplifies data sharing, making it effortless to provide data when it's requested. If the recipient is also within the IC ecosystem, the process remains the same. However, if the recipient exists outside the IC ecosystem, intermediaries may come into play. This is because external entities may not have yet implemented the HTTPS outcalls function, as it's a unique development specific to IC's canister smart contract. Applications of HTTPS outcalls. The potential applications of HTTPS outcalls are extensive, offering numerous opportunities, particularly in data retrieval. It can be utilized for tasks such as account verification via regular email to access a dApp within the ecosystem. It can be used for collaborative voting data within DAOs and governance dApps, for traditional voting applications during elections, and sports data for gambling dApps, allaying concerns about intermediary manipulation. The introduction of HTTPS outcalls on the IC blockchain represents a significant advancement in Web3 technology. This function eliminates intermediaries, enhancing security and transparency in data exchange. It empowers developers to seamlessly incorporate data from various sources and opens up a realm of possibilities for applications in Web3. The future looks promising for HTTPS Outcalls as it encourages broader collaboration and interoperability, further boosting the adoption of Web3 technology. This innovative development brings us one step closer to a decentralized and interconnected digital world. So, what are your thoughts on this groundbreaking function? Is it impressive? We hope this video has provided you with a clear understanding of this exciting technology.